So after being quite disappointed with this Nightlight thing, I decided to just convert it to a always on orientation light kind of thing, using some of these nice old IN3 neon indicators, or some people call these Nixies because they use them in Nixie clocks for some reason. Probably because they have a really nice squared appearance for the dot. Let me try to show that to you. If I get that to focus. Still learning with that camera. There it is. You can see there that it has a kind of square plate surrounded from that wire cage. And also another square plate just in front of it. So we have a nice glowing square if we power that with DC. If we don't, we have basically a blob, a neon colored blob, which is also good. But I like neon bulbs a lot more for night lights than these LED things. So I thought, why not try to convert this light using the same PCB that they have inside of here, just stripping most of the parts, putting new stuff in, and yeah, like trying to get a nice light out of that. So to start this project off, I will disassemble most of the components, probably all, and after that is done, or better, to do that, I will just shut up and desolder all of that and try to find some nice music for you to listen to. Basically, because I have no idea what I should tell you at that time, because this is just a very, very simple project. So enjoy some music and some desoldering action. And enjoy me burning myself on a hot wire. Let's get rid of that. So, after we have removed all that crap, we are ready to go on. As you saw, I decided to keep the fusible resistor in series for, well, no apparent reason, because this whole thing will have such a high impedance that it is very unlikely to fail in a catastrophic way anyway. But it keeps us from drawing another bridge around some pads here. So yeah, I think we could go on with populating that thing. For that I will just put one of these neons in here and see if they even fit inside this enclosure, because that is quite small and we do not have that much space. We probably need to be a bit creative with placement. Yeah, definitely. Put that aside for a moment. Yeah, that won't work. Let me see if I have some smaller neons. Turns out I have not, at least not right now here in the lab. So we have to be a bit more creative, but I'm pretty sure we find a way to get that to fit. Because, well, in this top part there is definitely enough room to make them fit. We just have to somehow get them inside of this plastic ring here. Let's see how we manage that. First we need to add the resistors. Why doesn't that fit? It does fit, it's just very tight. And no, I am not looking for nice optics here right now. It's just supposed to work, not to look nice. Let's get that here where the capacitor was. And already we have the input circuit done. Oh, by the way, I printed this strange looking but quite cool solder dispenser ring thing. Quite neat. Can highly recommend to do that. If you solder a lot, it helps a bit, as you don't have to search for your spool of solder all the time if you are a bit messy and placing stuff everywhere like me. By the way, I'm using 470 kilo ohms resistors, 2 of these, so to basically get 1 mega ohm. We don't want these to be driven very much. Probably going to bridge one of these later if they do not ignite the way they should, but we will see that. I did not do the calculations right now, it's just wild guessing at that point. So since we are using the position for the capacitor, this allows us to place one of these basically at that position, which makes total sense in terms of placement. Very nice. So, oh, I did not clear these holes very good. One moment, loud noises. That's better. Let's put that here. We can also use the wires of that neon here to bridge where the rectifier was before, which is helpful at that position. If you hear some rattling noises in the background, that is the compressor pumping back up from the desoldering gun. I hope it is not too annoying to listen to. Come on. Don't flee from the hot iron. Good enough. So we have one. And another one. Let's pick another one. We could use the position of R3, which would be here. Also, let's just quickly check which places we have to leave free, which would be the part for the light sensor, which is conveniently marked here. Maybe we can manage to do that. Let's see. And another one that I forgot. Maybe we can put that here. No, we cannot. There's that hole for the safety stupid screw. This might be a bit tight. Let's just stick that here and just, whoops, just nibble away this thing. Snip. Gone. Nobody needs that. So we can place that here. Solder that down. Snip these off. And a third one, maybe. We could probably put that one around the transistor position. That should work. We can place it like that. Yeah, that will work. So we have 3 of these in here. That should give definitely enough brightness. Maybe we can we put that, I wonder if we can put one around here to distribute the light a bit more, but no, not really, at least not easily. So let's just leave it at that. It's good enough. Let's see if that fits. It should. Yeah, it does. Let's see if that works. I got the extension cord, and I assume it won't work because I chose a very high resistance for 3 of these in parallel. It will probably either flicker a lot or doesn't ignite at all, but we will see. I see one of them ignited. Let's just remove the cover. Yeah, one is ignited and flickering quite a bit. So we reduce the resistance. Probably it should be enough to just jumper one of these, and I will, because of ease of reach, I will just bridge over that one here with one of the leftover resistors that we have. What is that one? And that's a 56 ohms, perfect. We just use that to bridge that here, if we manage to solder it somehow. Yeah, we got that soldered. Now let's try again. Still only one lid. I get the impression that we missed something. Well, stupid me made a mistake. Of course, only one of these will light up if I have them in that configuration, which we basically have. So at the moment, when the first one ionizes, it reduces the voltage, the burning voltage above itself or over itself, down to around, I think at these ones it's around 60 volts. So these other two that are not yet ignited will only see 60 volts. So they won't reach their striking voltage of 90 volts. So basically, whichever one strikes the first will light, the others won't. A way to circumvent that is to give each of these their individual resistor. That way it will work with 3 of these in parallel. Otherwise, you could, in theory, leave it like that and just have them run for way longer, because as soon as one degrades a bit, another one will take over, and that way 3 of them will share their lifetime, and that way we'll have a way longer lasting light, which will probably outlive me. So yeah, not quite sure if I want to leave it like that. No, I won't. I try to get a resistor in there, just for the fun. So I think I found a way to basically connect 2 of these with their separate resistors, which was quite a bit more work, as I had to do some clever resistor and positioning of the some clever resistor and neon positioning. As you can see with that one here, it's spun from that pin to this. So yeah, quite a way over. I also had to take a new neon for that because the pins of these ones were too short. So sadly only 2 neons for that experiment, but it will be good enough. So yeah, that fits. One last sanity check if I didn't do anything stupid. Okay, I do not expect any explosions, so let's try that again. Get the extension cord and let's see. We have 2 working neons, yoo-hey! Also, I noticed that one is reversed. I'm so clever. I am just so clever. Let me try to bend that over. Neon is reversed and, well, now at a totally different position. Yeah, but hey, still, it is in there and it is working. I already tried it. Now we just have to reassemble that whole thing back up again and see if it looks nice in the dark. Of course, I'm not using that stupid crab screw. Instead, we are taking a slightly less crabby one. Let's see what we can find in the sheer endless stash of screws. That might be a bit big. Let's see. Where's that screw so that I can compare? It is gone. Very good. I probably already put it to the trash. Let's get rid of that stupid thing. So let's just search for a fitting one. Maybe that one. Or why is that not magnetic? Let's try that one. Maybe this could work. Let's see. it could if that would fit. Let's take that small one again. Yeah, that feels great. Oh, this feels very good. Yeah, that is gripping nicely. We have a winning screw. So that is closed up again. Let's put that away. Put this away. Let's grab the extension cord and have a look if that fits. So, of course, under normal light we see basically nothing. But in the night, this looks very, very pleasant. Not at all as bright as the other one, just a slight faint orange glow. It's perfect to orientate in the night. Orient, whatever. To know where you are so that you don't hit your little toe on the corner of your bed or some kitchen appliance or whatever you want to visit at night. Yeah, I really like that visual appearance. Cool. Nice. I will probably get some more of these shitty limes. Good lord, speaking is hard today. I will probably get more of these shitty lamps and convert them so that people like me and the little ones don't hurt themselves at night. So, just as a comparison, I plugged this lamp into my power analyzer and just had a quick glance how we turned out. And I have to say I'm very satisfied with the outcome. It looks nice and we have a power consumption of 0.2 watts continuously with a power factor of 1.0, which is expected as this is just a purely resistive load. And yeah, we are drawing 800 microamps, and this is also pretty much exactly what we calculated, or better, what these neon lamps are supposed to draw. Very satisfying to see that we managed with very little effort to get a nicer lamp than the original one. Yeah, I am very satisfied.